All right, so we're just going to do this one example for our flex day. So go through and we're going to do domain and range, and then we're going to do all these transformations to this graph and put it on this graph here. This is not, a quadratic, it's not an absolute, just kind of a random function here. It is a function that passes the vertical line test. So before we get started on the transformation, let's just do the domain and range of the original. Okay, so domain, you always want to go from left to right. So there's no arrows on the ends of these graphs, so these are specific points that pretend they're filled in, even if they don't look like they're filled in. Those are filled in, so the graph stops at any of those points. So like, I'm not touching any part of the graph till I get to this point right here. If I'm doing domain, we just want the x value of that point. So the first x value I touch is -4. Now, as I continue, slide my pen like all the way across. I'm touching a point the whole time I'm sliding this across. I'm still touching points until I get right here. And then again, this is the last coordinate I touch. If I'm sliding from left to right, you want the x value. So this is going to be -4 and then -3. And we'll actually have little brackets there because we have, I don't know, these didn't come out really well in the copy here, but these are supposed to be filled in circles. So we have actual points there, so we should have brackets. Okay, so for the range, I'm just going to go from the bottom of the graph to the top. The range describes your possible y values. So you are not touching any part of the graph until you get to this point right here. The lowest y value I'm going to touch then is that -2. All right, and then the entire time I'm sliding up here, I'm touching one or in some cases more points, and that's fine. The function passes the vertical line test. This is a horizontal line I'm sliding with my pen here. Now the last point, or in this case points that I touch, I would touch these two at the same time, and that's fine. I just need to write down the y coordinate. The last y coordinate I touch is going to be 4. There's nothing above that. So brackets on all of this because we have actual points, and that's my domain and range. Okay, now what are we going to do to this? And we're going to put it over here. We are going to reflect this over the x-axis. So if I reflect that over the x-axis, I am just going to switch my x and y coordinates. Vertical shift down 2 units, we're going to subtract 2 from each y coordinate. Horizontal shift right 3, I'm going to add 3 to each x coordinate. Vertical shrink of 1/2. So a vertical shrink is going to affect your y values. So y values multiply by 1/2, and then we'll state the domain and range once we get that going. And actually, let me come back up here. Reflected over the x-axis, I should have written a description for that too. If you reflect over the x-axis, what you're going to do is your y coordinate's going to flip. So I'm going to do the opposite of my y coordinate. Sorry, I should have written that down as I was describing that. Okay, so what's going to go on with these points? All right, if I reflect this point over the x-axis, it would be the point -4, -3. Then we're going to scooch it to the, add 3 to each x. We would scooch it to the right 3, down 2, and then we would multiply the y coordinate by 1/2. So I'm just going to go through and do that with each of the points. So here, I'm going to write down the original point, -4, 3. So each transformation, I'm just going to jot this down. So the reflection over the x-axis would take that to -4, -3. The subtract 2 from the y coordinate would take that to -4, -5. The add 3 to the x would take that to be -1, -5. And then I did not leave myself enough room, so I'm going to slide this to the side just a little bit. And that last transformation, I'm going to grab a piece of paper, just like, all right, so then multiply the y value by 1/2, so this would be -1, this won't be a nice number, -2.5. We'll have to kind of estimate that. So that would be, after all those transformations, where that point would go. and I'm going to do this with each one. So -2, -1. If I apply that first transformation, reflect over the x-axis, it would be -2, +1. So this is the reflect. This is the down 2. This is right 3. And then the final one is the shrink 1/2. So I'm just kind of showing you step by step each one of these. So down 2, so this would be at -2, -1. Right 3 would be at +1, -1. And then to get that shrink and the final point, that last transformation, this would be 1, -1/2. And then I'm just going to continue that process. So I'm going to pause the video and do that, and you guys try to do that on your own. So pause the video yourself. Okay, so I kind of cheated there, did each of those transformations, and you guys can go through and feel free to pause the video if you want to go back and look. But I just applied them in the order they were written. And you could apply these in any order, that wouldn't really matter. I would do the reflection first, because the easiest thing, if you start with just the reflection, you just flip the y-coordinate. So each of these just changed to the opposite, down 2, so I subtracted 2 from each of the y-coordinates, right 3, I added 3 to each of the x-coordinates, and the shrink of 1/2, since it's a vertical shrink, a vertical is going to affect the y, so I just took the y-coordinate from each of these, and I multiplied that by 1/2, or you could divide it by 2, that'll give you the same number. Some of them were nice and some of them were not. It's okay. And my graph doesn't look the most perfect here, but you can see this is flipped over. The shrink is going to cause it to, can't see my hands, is going to cause it to flatten out. So it's a little bit wider, if you will, than the original. And these should be the points here on the graph. So the domain here and the range are going to change. So the domain, the first point I touch is this first one right here, and that's just the first one I have written. The x-coordinate there is -1, and I'm still touching part of the graph until I get all the way over here, and this point right here is 6, -3. I had to kind of extend my x-axis a little bit to fit that in, but the last x-coordinate I'm going to touch there is going to be 6. Now for your y-coordinates, approach from the bottom, the first y-coordinate I would touch would be these 2 points at the same time. The y-coordinate there is going to be -3. And what I'm going to do here is I'm going to continue. The last y-coordinate I would touch would be this point right here, and that has a y-coordinate of 0. And that should be my range from -3 to 0. Nothing above, nothing below that. And that's an example of a transformation, all these different things that we've talked about with just a function that's not something you guys have seen. It's not some radical necessarily. It's just a random graph, and we're able to transform that using those rules.